ये मीठा लगा मुझे क्या सब्जी ना हाँ इसमें डाला है वैसे आपके काफी सारे इसमें वो डाले तो कड़े वाले स्पाइसी डाले और हालांकि मैं तो दम आलू बनाती हूँ आपको मैं आती हूँ मैम जस्ट सेकंड ना मुझे रिप्लाई करने से हाथ धोना पड़ेगा
So, very good afternoon, friends. I hope you took lunch and then relax. So now we'll do the diffusion of A through non-diffusion of B. So chapter number 1, diffusion, is going on. We have a topic, steady state molecular diffusion through a constant area in a binary gas mixture. So it means that we take a steady state molecular diffusion. It means that molecules are going from one place to another place, and it doesn't change with time. So with respect to time, constant molecules are going. And then we take a constant area is not changed, and we take two component in a gas. We take two component binary gas mixture. It means the one gas having two components, and we'll follow these conditions. We follow steady state molecular diffusion. We'll follow constant area, and we'll take binary gas mixture. It means the gas having two components, and then in that subtopic, we'll take case number 1, diffusion of A through non-diffusion of B. We take diffusion of A through non-diffusion of B.
B is chemical engineering, chemistry camp, but now with chemical engineering, material science, chemical engineering, material science.
Okay, so let's take this topic. But what will keep in your mind? We take steady state molecular diffusion, we take constant area, and we take two component in gas. It means a binary gas mixture. And the case we take diffusion of A through non-diffusion of B. Okay, so let's derive the equation of diffusion of A through non-diffusion of B. We'll take one example, and based on that example, we'll do it. Huh? Okay.
आपने ऊपर से कुछ डाला है
हाँ मैंने ऑलरेडी डाला ना इसके अलावा कुछ नहीं डाला इतना ओसी
शेम देश बस नया पाउडर है
Case 1, diffusion of A through non-diffusion of B. Okay. So, what do you mean by diffusion of A through non-diffusion of B? For examples, I have one equipment. The equipment is look like this, and we have a constant area. We have constant area. Now what we'll do? I will inject a gas. Gas having two components. One having air and one having ammonia. Ammonia air. This is flowing from using blower, flowing from upper. Now what will happen? Now we'll introduce water. One solvent from here, and they are going from upper side to below side. And what will happen? So two components. One is ammonia air, that is B. One it is ammonia air. Now what will happen? Ammonia will transfer into the water, while air will not transfer into the water. Gas having two components, air and ammonia. Now, for example, okay, air, yes, it's just for explanation part. Yes, ammonia will dissolve in water, while another B air will not dissolve in water. For example, now what will happen? Only A will diffuse from air to the liquid. Only A will diffuse molecule from air to the liquid, while B is not diffused from gas to the liquid. Air will not diffuse, only ammonia will diffuse. It means that only diffusion of A. It means that only ammonia will diffuse through and non-diffusion of B. It means that ammonia will not, air will not diffuse from air from gas to the liquid. So only A will diffuse, other will not diffuse. It means Na, and we are saying that it's a steady state. So it means the molecular of diffusion A will be diffused, but it's a constant. We'll have some value, it's a constant. While B is not diffusing, so we said NB is equal to 0. And here steady state diffusion will be there. with constant area. So we take Na is equal to constant and Nb is equal to 0. And what will be the example? Example of ammonia A being absorbed from A B, air will be into water. This is the example of diffusion of A through non-diffusion of. Okay. So any doubt within these students? You have problem within this 3-line? Did you understand this concept? The students, any problem within this? If we are clear, then we go further. If we are not clear, then we understand one more time. Anyone having down, can you write it down in chat box, or you can not unmute yourself because my still handphone is not working. But you can write down in chat box if you have any doubt. I go further, students. Should I go further, or any repetition is required in this 3-line? Did you understand? I get an answer from one student. Kindly say 2 or 3 students so that I can go. I get the answer from Bhumik, but I need answer from more students. If you have doubt, then tell me. Okay, okay. Thank you, Manas. Guys. Thank you, sir. Now, here the gas is there. Gas component will be there. So what we write down? We have to write down the equation in terms of the pressure. We cannot write down the equation in terms of concentration. Whenever liquid will be there, at that time we'll write down the equation in terms of concentration. But whenever in here it is a gas there, so we have to write down the equation in terms of partial pressure, in terms of pressure. So let me write down. So Na is equal to Na plus Nb. So we write down Na is equal to first we write down in terms of concentration, then we'll write down N. Let me start from here. Ca divided by C minus Dab dCA divided by dZ. Okay, now here the gas component will be there, so we have to, we can also write down like Na plus Nb is equal to Ca divided by C minus Dab dCA divided by dZ. And here we say that Nb is equal to 0. Here we say that Nb is equal to 0, so we call as a 0. So what we have written down? We write it down Na is equal to Na Ca divided by C minus Dab dCA divided by dZ. I hope it is clear up to this. And nothing but we write down the equations we have already in our previous lecture. We put Na is equal to Na plus Nb. here we say that we have a case where NB is equal to 0. Diffusion of B or flux of B is 0 for in this case. So we put NB is equal to 0. So NA is equal to NA minus CA divided by C minus DAB divided by DCZ. Now I'm writing down here. Now here we have gas phase, so we can write down equation in terms of pressure. So Na is equal to Na in terms of pressure, so Pa divided by P, partial pressure divided by total pressure. Instead of concentration, we write down partial pressure. Now PV is equal to nRT, where for example PV is equal to nRT is an ideal gas. P is equal to N by V multiplied by RT. N by V is equal to CRT. So C is equal to P divided by RT. So we put concentration here is equal to RT divided by dPA divided by dZ. So we'll write down this equation based on these conditions. Any doubt within this equation number 1? Any doubt within this, you can write down in chat box. So how many marks does this ask? Yes, this one is for 8 marks. Very good. Thank you for reminding me. It asks for 8 marks. Very good. 8 marks. Okay, repeat once. We have this equation in terms of concentration, but this is applicable whenever liquid phase is come. We said that alcohol plus water, that's a liquid phase. Now here we say that it's a gas phase here. Air, ammonia, they are in gas phase. So what we can write down in terms of partial pressure. Whenever liquid phase is there, at that time we can write down in terms of concentration. But gas phase will come at that time, we can write down in terms of partial pressure. So Ca into Pa, total C into the partial pressure, PV is equal to nRT. So P is equal to N divided by VRT. We call number of moles per volume as a concentration multiplied by RT. So concentration is equal to P divided by RT. So here instead of Ca, we can write down Pa divided by RT. Well, partial pressure can change, but gas constant and temperature remains same multiplied by dZ. So Bhavin, still I repeat one more time, or now you understand? Should I go ahead, Bhavin, or still I repeat one more time? Okay. So now, okay, very repeat again. Repeat. Okay, Vicky, you are saying repeat. Okay. So we derive this equation in previous one. We write down this equation previous one. Whenever liquid phase are there, Vicky, at that time we can write down in terms of concentration. But whenever gas phase is there, at that time we have to write it down in terms of pressure. Yes, temperature remains same all time because isothermal, there is no here in absorption column, no change in temperature. Aryan, you are right, exact time. RT, T will be constant, R will be constant, but partial pressure is changed. So here instead of Ca we write down Pa, total pressure write down PA. Now we, instead of CA, we have to write down in terms of pressure and temperature. So PV is equal to nRT, P is equal to N divided by VRT. N divided by V called as a concentration. Number of moles per volume is a concentration. CRT. Now we require concentration, so concentration is equal to pressure divided by RT. So instead of CA, we can write down PA divided by RT. So instead of CA, we can write down PA divided by RT. So we write down CA instead of PA divided by RT. So now we have to use this equation to do further. So let's do. So I removing all these things because I require whole whiteboard for the derivations. And this is must 100% will ask in exam. 110% this will ask in exam, either example or theory. Okay, so now finally we arrived this equation. Na is equal to Na multiplied by Pa divided by P minus Dab divided by RT dPA divided by dZ. Sir, E content માં છે E content ની અંદર ના, just I share two books with you. I think before 2 days I shared two books in your login in your WhatsApp group. So I think please download from the book content this one. So what we have to ultimately what we have to find out, ultimately we have to say the how the flux is going on. Ultimately we have to find out Na, but there are two different cells will be there. dPa will be there and dZ will be there. So we have to separate plus dPa with dZ. We have to separate dPa with dZ. So I think first we can write down like this: Na minus Na divided by Pa divided by P is equal to minus dAp divided by RT dPa divided by dZ. Let's first write down like this. So Na will be constant, so we can write down Na 1 minus Pa divided by P minus dAb divided by RT. In books, all steps are not written, but we will derive with all information. So I can write down like this also: Na P minus Pa divided by P is equal to minus dAb divided by RT dPa divided by dZ. Now what happened? This side dPa, this side also Pa and P, this dZ. So what we'll do, we take dZ this side, P minus Pa this side. So dPa will also be integration and dZ can also be integration. So I'm writing down here, students. Let me write it down here. So I rearrange this equation. How we arrange this equation? Na is multiplied by dz is equal to minus dab divided by rt. This p will go here, so I am writing down p here, and dpa divided by p minus pa. And so I rearrange this equation like this. Any doubt up to these equations? I will write down this 1, 2, 3, 4, 5. Any doubt within these 5 equations? If you understand, then I go forward. If you don't understand, then tell me. I will tell each and every steps. Okay. So I go further. Now we'll do the integrations. Why you Kishan, you write down your number? There will no attendance will be taken in this lecture because I will take the attendance of previous lecture. It is applicable for both. So NA, now we'll integrate it. Limit z will be the distance. We are saying that z will be distance. So 0 limit to L length dz. Ultimately z is a distance direction from this one to this side. 0 here having a z, so we can dz. We will call as a 0, and here total length L. So we take from 0 to total length L is equal to minus dab multiplied by p divided by rt. Here we integrate from 0, partial pressure is 0. From 0, partial pressure is 0, and from L direction, total L, partial pressure is PAL. Then we take dPA divided by P minus PA. And P minus PA. Okay, any doubt within this integrations part? Any doubt within these equations? Understand? From 0th limit, partial pressure is 0. From L length, partial pressure PA. Okay. Now we'll do the integration. One thing is there, I don't know how to do integrations. Any students will help me the answer of these integrations, because Hiran sir will teach you the mathematics, and Hiran sir is a master in mathematics. So I understand you are also a master in mathematics. But I teach maths in 2006, and still I forgot the mathematics. So anyone will help me for these integrations? Can you write down answer in chat box if you know integrations? Okay, once I say upper limit minus lower limit and separate. Okay, so I'll try. Whenever if you find any mistake, just tell me. Na multiply by L, then is equal to minus dab multiply by p divided by rt is a constant. If you find any mistake, just tell me. Ln p minus pal divided by p minus pa0. Any mistake in this integration? Because I don't know much. If this is wrong, then you have to tell me. If this is right, then you have to also tell me. This is correct, students? This integration is correct? Or I have to make plus sign. If I make plus sign here, then it's correct. Here is a plus sign because we we will separate this one. So that's why here minus and minus becomes plus sign. Mitesh is I think not wrong, sir. Anyone from Manas, Raj? Manas, Raj, or in any students, it is. If it is wrong, then tell me. So I change it. I change it. So I yes, PA minus PA0. Okay. I can also write down like this equation like this also. NA is equal to DAB P RTLN P minus PAL divided by P minus PA0. Yes. Okay. We can also use this equation, and in another way we can also use these equations. Why we have to do this, that I will explain you. So if this one is correct, I think. Huh? Okay. So let me go further. Let me first derive it, then I will tell why we have to do, why we do this. Okay. For examples, okay, I can write down like this. Total pressure is equal to PA0 plus PB0 is equal to PAL plus PBL. And total pressure is equal to initially sum of partial pressure of component A plus partial pressure of component B plus at L position partial pressure of A plus partial pressure of B. I can also write down like this. PA minus PA0 is equal to PB0, and I can also write down like PA minus PAL, P minus PAL is equal to PBL, and I can also write down like this. PA0 minus PAL is equal to PBL minus PB0. From this equation, I can write down this one. From this equation, I can write down this one. From this equation, I can write down this one. Okay. So what we'll do, I will do like this. Na is equal to DAB P RTL. Now I am here nothing, but I can write down 1. Here it is nothing, but I can write down 1 ln. P minus PL, it means PBL. P minus PA0, it means I can write down PB0. Now I here nothing, but we can say it's a 1. It's a 1. So I can write down like this one. DAB multiplied by P RTL PA0 minus PAL divided by PBL minus PB0 ln PBL divided by PB0. Here is a 1. Instead of 1, we can write down ratio of these two. If I go this one, then it becomes a 1 here. So I can write down like this also. You understand this part? Left side, you understand? Anyone having a doubt? So that I explain one more time. It's clear? All students clear with this? Okay. Now, okay. Again when I rearrange this equation, so finally my answer is Na is equal to DAB P divided by RT. Now I'm writing down like this. Please careful with these writings. PA0 minus PAL divided by PBL minus PB0. Now here this come in this side, ln PBL divided by PB0. This one will come in numerator and this will go in a denominator. If I write down like this, it's also correct. If I write down like this, it's also correct. Both are same. And we can say PBM. It means logarithmic mean pressure difference is equal to PBL minus PB0 divided by ln PBL divided by PB0. So we can write down PBM where NA is equal to final answer DAB PRT. Here it's L. I forgot to write it down. L PA0 minus PAL divided by PB. This is the final answer. If diffusion of A through non-diffusion of B will be there, at that time we can flux this one. Any doubt within this? This is called a logarithmic mean pressure difference. For example, here is a PBL. Here is a PB0. So each and every person, if I want to find out a pressure, so for this mathematically I can write down this one. This will also come in your heat transfer during the heat exchanger. Once you study the heat exchanger, at that time one term will be there, logarithmic mean temperature difference. And this is the logarithmic mean pressure difference. So this is the one way to write it down. If you write down pressure in each and every person, then instead of it, if I write down like this, then we can, it's a mathematical terms. Maybe it will come in your mathematics, I don't know, but this one is a pure mathematical terms. And this also come in your heat transfer. Now this is the derivation from my side. Now any doubt within this, you can ask me a question. I can clear your doubt. Now I think my headphone is also working. It's connected, so you can also unmute yourself. My headphone is also working right now. So you can unmute yourself. You can ask me a question. You can unmute yourself if you want. Any doubt within this? All of you understand, or this is the last lecture, so uh, uh, it's really all of you understand these derivations. Students are from international students. Any doubt? Okay, last three steps. Okay, so let me. Uh, I will start from here, or I will start from here. Okay, let me start from here. Here, 19 number is nothing but we can write down 1. Here, nothing but we can write down 1. If I take a ratio of these two, I can write down like this. PA0 minus PAL divided by PBL minus PB0 is equal to 1. These steps. And so instead of 1, I write down these steps. Then now what will happen? I will go this one to this side. This ln will terms go in this side. So this will come. Now this whole quantity will called as a logarithmic mean pressure difference. This one is called a logarithmic mean pressure difference. So once you have a two limit, and within these two limit you have a different pressure will be available. Then to find out the mean pressure difference, mean logarithmic, at that time you will use this equation. It's a pure mathematical term. So instead of PBL minus PB0 ln PBL divided by PB0, we write down here PBM. Huh? So all things are remain the same. So if you don't understand right now, but you will understand this one in heat transfer also. Here also come logarithmic mean temperature difference, and here logarithmic mean pressure difference. So in between, many partial pressures are there. So instead of writing down it, we can also solve using this mathematical equation. I hope I reached to you 19 number. So we'll calculate. Now what we have to do? There is a question. Is there in your screen? Okay. No, this will not. Okay. What I would like to say, kindly kindly take a screenshot of this question, and we will solve this question in next lecture. Please take a screenshot of this question which is there in your screen, and try to whenever you are free, try to read this example, and try to think what will be the answer, and we will solve this one in the next lecture. And we also calculate one example based on the current derivation. So this is the end from my side. Next lecture we'll calculate the example, and we'll solve this question which is there in the screen. So and we already take the attendance in previous one. So those who already write it down their number in previous lecture, they can leave the meeting, and those students who are absent on 11:15 to 12:15 lecture, they can write down their number here, and they can also leave the meeting. Those who already write it down their number on previous lecture 11:15 to 12:15, then they will not. Then if they write, then it's okay if you don't write it down. But if you are absent in first lecture, then you can number. You can also leave the class.
सेंटर्स में जाओगे कॉलेज का अपना वेबसाइट है, इसमें सेंटर्स में जाओगे एसएसआईटी एंड रीजनल एसएसआईटी में जाओगे
Students, I end meeting here. We'll meet next class within the new topic. So I end meeting here.